Hello everyone, and welcome to today's session on multidimensional arrays. In this session, we'll explore what multidimensional arrays are and why they're so important in data structures. We'll cover their definition and core concepts, discuss array creation and initialization, demonstrate how to access and modify elements, and look at practical examples and common use cases. I'll also outline the demonstration segments that will help visualize these concepts. Let's begin. Let's start with the definition. A multidimensional array is an array that has more than one dimension. Essentially, it is an array of arrays. This type of array is commonly used for representing matrices, grids, or tables. Key characteristics include rows and columns. They are often visualized in a row and column format. Indexing. Elements are accessed using multiple indices. Memory layout. Depending on the programming language, the array can be stored in either row major or column major order. A visual demonstration on this slide shows a diagram of a multidimensional array with labeled rows and columns, which will help you visualize these concepts. To see this in action, let's write a program. So to do that, let's jump into the Visual Studio Code. We are into the Visual Studio Code. As I mentioned earlier, a multidimensional array is essentially an array of arrays. In our example, we are using a 2D array, a matrix, to represent data in rows and columns. This is useful for many practical applications such as grid-based games, image processing, and mathematical computations like matrix operations. We are creating a 3x3 matrix by declaring an array with 3 rows and 3 columns. The matrix is directly initialized with specific values at the time of declaration. This step shows how we can set up a multidimensional array with predetermined values. Multidimensional arrays allow us to access elements using multiple indices. In this example, we are modifying elements by directly accessing them with their row and column indices. For instance, we update the element at the first row and second column, index 0, 1, to a new value, and similarly modify another element. This demonstrates how to both retrieve and change data stored in a multidimensional array. A common use case for multidimensional arrays is performing operations on matrices. In our program, after modifying some elements, we compute the sum of each row and each column. Calculating these sums is a practical example of processing data in a grid format, which can be applied in areas such as statistical analysis, computer graphics, and scientific computing. This example highlights how multidimensional arrays facilitate complex data manipulations and computations in C++. When you run the program, the output is produced in several stages. Initial matrix. The program first prints a 3x3 matrix that was initialized with the values. This grid-like display shows the original arrangement of values before any modifications. Matrix after modifications. Next, the program updates 2 specific elements in the matrix. The element in the first row, second column, originally 2, is changed to 20, and the element in the third row, third column, originally 9, is changed to 90. When the modified matrix is printed, it appears as follows. This output confirms that the modifications have been correctly applied. Row sums. The program then calculates the sum of each row in the modified matrix. The sum of the first row is resulting 24. The sum of the second row is resulting 15. The sum of the third row is resulting 105. These sums are printed with a clear label indicating which row each sum belongs to. Column sums. Finally, the program calculates the sum of each column. The sum of the first column is 12. The sum of the second column is 33. The sum of the third column is 99. These results are also printed with labels, indicating the sum for each column. Overall, the output demonstrates how a multidimensional array can be created, modified, and then processed to compute useful aggregates such as row and column sums. Now let's go back to presentation to summarize it. Multidimensional arrays are a fundamental data structure that allows us to represent complex data like matrices, grids, and tables. We covered their creation, indexing, iteration, and advanced concepts like memory representation and performance considerations. Understanding how to access, modify, and efficiently iterate through these arrays is essential for many programming applications. I now invite any questions or discussion points you might have about multidimensional arrays. If you have any questions, send me in comment section.